Okay, I just thought I'd do a real quick video. I got PWM test mode going with Lebowski's program. Basically, right now I'm just testing both gates on the high and low at the same time. Right there you can see the dead time is right around, if I can get the cursor here. Yeah, the dead time is right around the 500 nanoseconds, spot, just like I programmed it in there, if you actually see that there. So that's pretty cool. You can actually see the blue trace, which is the I believe that's the low side FET turning off. It's not quite all the way off before the other one starts transitioning on, so not sure if that's going to be a big deal, but I've got a bit of a stage here. I'll explain it. Basically, between my FET drivers down here, I have my diode with a 2 ohm resistor in parallel to it. The diode is for quicker turn off times than on times. Then from there it goes out to all my gate resistors. These here, it's safe to touch, are individual gate resistors. They're all 10 ohms. So the diode is essentially allowing for off time with just a 10 ohm gate resistor per gate, and the on time is a 2 ohm gate resistor, then to each separate 10 ohm gate resistor after that. That's on both sides. I've done it that way. So I'll switch this probe so we can actually see my transition here. So now that's on my drain to source. Basically I'm on the low side drain to source, so you can see it here. It looks really nice. You can see just a tiny little bit of ring in there, but like really there's no overshoot really, like maybe 2 volts I think I measured it at. So let me just scroll up there. Right about there, yeah, 1.6 volts overshoot, between there and 2 volts anyway. And one other thing I wanted to go show was when I'm on the other gate, watching this gate on my off. So this is now hooked up to my low side gate. I had problems with this before, and this is part of the reason I do the diode trick. You can see the little spike down there. So that's actually the transition of drain to source. Basically the voltage swinging up, trying to pull the low side gate back on. So it's around 2 volts right now. I've got 2 packs of 4S LiPo hooked in series. So basically 8S hooked up to it, so 30 something volts right now. It's, you know, I don't think it's going to be that big of a deal. I'm going to have to test it more, but it's definitely, I think I remember before that when I had this problem, it got worse as I upped the voltage, but I have to double check. Now that I have the diode trick there, I can adjust it. Yeah, around 33 volts basically from the batteries right now. Everything seems to be switching pretty good. I think I got it pretty close. Get your guys' opinion if you think I should change anything more. I did have originally just the 10 ohm gate resistors, had lots of ringing. This diode, oh, and that right there, there is, get my finger in there carefully, that's the ferrite bead, kind of like Luke suggested, except it's a bigger one than suggested, but it works. It's the only one I had in stock. I ordered what I could as I was kind of Googling all this stuff and searching around on the forums and everything, learning everything I could. So anyways, that definitely, putting that in the series with the whole system, that's before all the gates. Basically it's between these two, the resistor diode, then it goes to the ferrite bead, and then it goes to all the gate resistors. So I think it's a pretty good system. Sure, I'm going to redesign this. I want to shrink these boards up. I think I got them redesigned already where I can fit them on a 4-inch piece of C channel, and then they're about 4 inches wide, so it'll be about 4 inches by 12 inches, and then whatever height. I'm going to cut this C channel down right here, so I only have to fit the cooling fans in the bottom. I don't need it that tall. But yeah, it should work pretty good. I think I got it just about ready to start running a motor. I'll just get your guys' opinion and then we'll go from there.